Glycolysis is the initial metabolic pathway of cellular respiration, in which a series of reactions happening in the cytosol results in the conversion of glucose into pyruvate and the production of high-energy molecules such as ATP. The yield of ATP is produced by substrate-level phosphorylation, which is a type of metabolic reaction that results in the formation of ATP by the direct transfer and donation of a phosphate group to ADP from a phosphorylated reactive intermediate. Throughout glycolysis, there are many intermediate products that are produced by the breaking down of the original glucose molecule. There are about 10 enzymes that break down these intermediate products to proceed with the process of glycolysis. In the first step of glycolysis, glucose is broken down by the enzyme triose phosphate isomerase into two molecules of phosphoglyceraldehyde, which contain a single phosphate group. This is ATP-driven, using up two molecules of ATP, producing 2 ADP. Next, the two molecules of phosphoglyceraldehyde is broken down by the enzyme triose phosphate dehydrogenase into two molecules of biphosphoglycerate, which contain two phosphate groups. In this step, 2 NAD+ are reduced to NADH. NADH will then proceed to the electron transport chain. Then the enzyme phosphoglycerokinase removes one of the phosphate groups from both molecules of biphosphoglycerate and phosphorylates an ADP molecule to create ATP. Since this occurs twice, it creates 2 ATP and 2 molecules of phosphoglycerate, which now only has one phosphate group. Finally, the enzyme pyruvate kinase removes the remaining phosphate group from both molecules of phosphoglycerate to phosphorylate another 2 ADP, producing 2 ATP and 2 molecules of pyruvate or pyruvic acid. Pyruvate will then continue onto the Krebs cycle, alcohol fermentation, or lactic acid fermentation. Glucose reduces 2 molecules of ATP to ATP and is broken down into 2 3-piece molecules of phosphoglyceraldehyde. The 2 phosphoglyceraldehyde molecules reduce 2 NAD+ molecules to 2 NADH molecules, producing biphosphoglycerate. The 2 biphosphoglycerate adds a phosphate to the 2 ADP molecules to create 2 molecules of ATP, creating phosphoglycerate. The 2 phosphoglycerate molecules add a phosphate to another 2 ADP to create 2 ATP, then creating 2 pyruvate molecules.
I don't see how you can eat from outside the cell. You can't even get in. Without insulin. Let go.
Glucose in the cell by translocation. 1 phosphate added, 1 still missing. Yeah, that looks like a G6P. I get this 2 ATP. In 10 steps, cells love me. I make pyruvate. If you get what I get, then I got my way. He teach it all to us. Dr. Burns. In the S6P to heart and lungs. Look at me now. Look at me now. I'm making energy. Look at me now.
Oh.
Look at me now.
Yeah.
Compared to a G3P.
13-PPG bigger than G3P, because I'm killing every G3PG to get my 2PG. Gotta cut that 2PG because I'm trying to get my PEP. We accidentally slipped on pyruvate. Oops, I said pyruvate. I didn't really mean to say pyruvate. Since we talk about pyruvate, let's just say hi to it. I'm done.